Well, Ryan and I are going to be telling the story of taking our application from no code all the way to production using Tanzu Application Platform. It's going to start with me, the developer, in my inner loop. And the inner loop is my personal environment for building my application. Right? As a developer, I mainly need three things easily available in my inner loop. Number one, I need a good starting point. Number two, I need good tooling. And number three, I need an easy and consistent path to production. How does Tanzu Application Platform improve my inner loop experience? For my starting point, I'm going to use Application Accelerator here shown on the screen to start my new application. Oops. And I have an accelerator starred here. It's called Spring Sensors Rabbit with Tilt. And basically, this is going to be a template that's going to help me or anybody else start a similar application to this. So let's look at this repository. It's backed by a Git repository here. And there it is. It comes up. It looks a lot like a normal Java application repository with a few exceptions. A couple of things to point out before we move on is the workload file. And so this file is with Tanzu Application Platform, this is going to be the only file that's required for a developer to build and deploy an image to Kubernetes. So there's a few things in this file. We'll talk more as we go along in the demo, Ryan and I. But there's some substitutions that will be done when I actually use this accelerator. You can see I have highlighted on the screen this word and then another word, which will show how it's substituted in the accelerator when you use it. And the other thing is a tilt file that's in my accelerator. And this is basically going to help us use my live code on my desktop in a Kubernetes cluster as we go along. All right, so let's actually use this accelerator. So I can choose it. And there's a bunch of questions here that you can change in this form to fill out, which will build or transform the files as when I download it. I have everything pre-filled here on the accelerator that was built, so there's nothing that we need to do here. But just to show you what you can do, if you want to make changes to these forms, I can hit a 2 on my Git repo line here. And if I say explore and I go to this file, you'll see it says 2 here, right? So you can make changes to this form and actually look at it before you download it. But let me get rid of that and go to next step and actually download this zip file using the accelerator. So this is going to create a zip file, do all the transformations that I need. Now I'm going to download it to my desktop, and now I can start coding. So that's number one. I got my starting point. And now that I actually have my code up and running, I already extracted it and moved it over to save some time here. So I have this open in VS Code right now. And we can look at the workload file that we're talking about here. It's already up on the screen. You can see it actually transformed and using the correct tagging and Git repository that we have created. And then the tilt file is here as well. And so before we actually get started, so what I want to do is I have a local Kubernetes cluster. It's actually running in GKE, but it's my development cluster that's enabled with TAP. And right now I'm on the command line down here in the bottom part. You can see I just did a Tanzu command to see if there's any workloads, and there's nothing running just yet. And I want to run my source code that I just downloaded from that accelerator in Kubernetes right now. And so I just want to right click on this tilt file. So the developer only has to go on here and do a Tanzu live update start. And basically we'll start to see a bunch of messages come up on the screen that's kicking off the supply chain. So the supply chain that's part of Tanzu Application Platform is being called because this workload file has been deployed to Kubernetes. So the supply chain it's based off of labels and selectors, and it's using this web selector to run the supply chain. Now this supply chain for my development cycle, it's only going to do a build with Tanzu build service right now, and then it's going to deploy my application once it's built to Kubernetes. Let me see what's going on here. I just deployed it in my default namespace. And we can see the build pod here is running in my local names in my default namespace.
Excuse me. So a question about this, because I think the intent, and correct me if I'm wrong, the intent is to help developers who are solving business logic not worry about the underlying Kubernetes infrastructure. So when you say terms like supply chain, it's I have a business logic problem. I write code, I hit push, and then magically it's it's in my infrastructure. But you just showed me a show kubectl command. Yeah. Is that like for people who are more aware of the underlay, or what's the point of that?
The kubectl command during this demo is obviously just to show you the pod running. Mm-hmm. As a developer, if you don't need to do that, you could just watch the logs while it's building here. So the kubectl, I'm just doing that to show you pods getting started up within my environment. But the developer won't need to know that in this environment, right? So right now I'm in my GKE environment using a supply chain. And then when I hand it off to Ryan, when I do a pull request, when I'm done with my code, Ryan will be simulating the production supply chain, which has a lot of the same parts. So the supply chain shares the building process and all that together. But as far as the kubectl command, it's not really needed. It's just
I'll add some additional context there. This is obviously Kubernetes is the foundation here, and we're building abstractions on top of that to simplify the path to production and the developer experience. But at the same time, it's just Kubernetes. So this all kind of zeroes out as CRDs and experience on top of Kubernetes. So if you do need to go to down to that lowest level of infrastructure to make some type of optimizations, you can do that. So there's flexibility there to do that from an operations or a scale point of view, or even a development point of view. So we don't hide that from you. We just make it easier to use with our abstractions on top of it.
So as a favor to us, as the team is going back in between personas, whether you're the application developer versus the platform team, or however you're breaking it down, if you can just tell us when you're switching context, so that we know. We've found that difficult because in some environments, this is one person. And in other environments, it's 80 people. So just to help us with context.
All right, so the application is up and running in the browser now. So this is just the Tanzu Sensors database. It's running live in my code. And say as a developer, I want to actually make a change to my code while it's running in the cluster. I'll just go change the name. If you saw here, it says Tanzu Sensors database on my screen. I want to change this to weather. So we're just going to simulate a quick source code change. And all I'm going to do here is do a Command S to save this. And we'll actually see the logging happening here. Yeah, so you saw that Spring message scroll up on the screen. So it's actually updating the running container on the Kubernetes cluster. And so when that gets done, we shall see when this comes back up. It'll say weather. A little delay here. All right, still waiting for it to come up. All right, so it should say weather. There we go. So the change happened live on my Kubernetes cluster running my local source code. So that's using the Tilt open source tool integrated with the Tanzu Application Platform supply chains to push that out.
And so now, I'm sorry, was this developed environment pre-configured for you? Like, how did you get access to the actual underlay to
the cluster itself?
Yeah, the cluster itself.
Yeah, so I mean, it could be any Kubernetes cluster that has the TAP components installed. It can be on my laptop, a Kind cluster, a Minikube cluster. But right now I'm using a GKE cluster that I simply ran the one command to install the TAP components in it to enable the supply chain. All right, so here I'm actually, now that, all right, this isn't working. Let me start anew. as a developer here, I just basically want to check in this code. Oops. And go to my Git repo and create a pull request. And that's basically going to be the handoff to Ryan. So this is my Git repo for that code that I was just running in. And I'm just going to create this pull request. And so now the operations, whatever automation or manual process we have to actually start in production, this is where the operations side would happen, would start to take over. So I'll give it over to Ryan now.
All right, cool. So Aaron just finished up as the developer role in the inner loop, and that's really where he's going to focus as a developer, is in that inner loop where, as he discussed, he uses a starting point, which is the application accelerators. He uses those toolings in the IDE, so the app live view, or sorry, the live update plugin that he showed. And then he starts to expose the path to production. So now that he's finished that up and completed his role as a developer and getting that application built and committed, we're going to pick it up in the outer loop. So this is where I'm going to take over as the role of an operator. And my focus here is really to ensure that Aaron, as a developer, has a smooth path to production, and one that's pre-approved, predefined for my organization's best practices and any of the steps that I have defined as a way to get an application into production. So in the outer loop example here that we have things such as testing your code, so making sure that unit tests, integration tests are run, and then actually building the container. So building the container, signing it if your organization requires all container images to be signed, scanning it for any vulnerabilities. So making sure that you're shifting that left and making sure that no vulnerabilities are being exposed as they're being deployed into production. And then finally, obviously, deploying the application and running the application. So as an operator, I want to make sure that I have this path well defined and that Aaron doesn't have to worry about it. And most importantly, I'm not a roadblock to my developers, right? No operator, no DevOps team wants to be a roadblock and wants to be constantly in the way from developers getting their applications into production quickly. So that's really what the Tanzu Application Platform is focused on. So before I dive into this, one of the things that I really want to focus on is how we make a smooth and graceful handoff between our dev and our ops teams instead of having a throw it over the wall mentality. So let's dive into some of those things. So one of the things that Aaron talked about was that he has a personal development cluster. So what we like to think about, and what I really like to focus on as a previous DevOps engineer, is ensuring that we have consistent clusters between our development and our production environments. So he talked about his personal development environment. As I work through my supply chain, I'm going to have my production cluster, but keep in mind that those clusters are both running Knative with the Tanzu application platforms. They're going to have a lot of the same conventions applied. So it's going to be very consistent. So you're going to remove a lot of those environmental variables that are typically plague dev to production promotions. The next thing is repeatable container build. So it's very important as you move from development environments to production environments that you have a repeatable process to build containers. So we use the Tanzu build service that gives us through cloud native build packs the ability to reproduce a repeatable container image so that you ensure that while Aaron's building in his development environment, that it's going to be consistent with what we're building and deploying into production. And last but not least is using similar Kubernetes conventions. So Aaron didn't do a deployment using Docker Compose or some other sort of local development tooling that will be completely different than what's going to be used in production. He actually used the TAP platform to deploy it out to a live Kubernetes cluster with similar conventions, similar configurations it's going to get deployed to in the production environment. So again, mitigating a lot of those configuration differences that typically occur as you run through dev to prod promotion lifecycle.
So Ryan, this was much of the conversation I had at KubeCon in the hallway track. Some of the back channel here with the delegates, what's not completely clear and super critical is this personal development, this consistent cluster thing.
Yeah.
If Aaron is a low code, no code developer, he doesn't know how to deploy TAP. How did he get his that consistent cluster so that what he does on his laptop is pushed to your team for deployment? What's that process?
Yeah, so there's a really lightweight install for TAP, and we use TAP profiles. And I think I'm getting your question here. So if I'm going in the wrong direction, please stop me and I'll refocus. But so we have a really simple install process for developers specifically, where it's a lightweight TAP profile. So if he's using something like Kind or Minikube locally, he can just deploy that locally to have all of the same configurations that they'll have in production. If it's something that's in, GKE or AWS or, a not on-prem or on laptop cluster or even an on-prem cluster, it's something that the operations team could provide for them. So here's your personal development environment, right? As part of the onboarding where it's pre-installed for them. We actually just published this morning a YouTube video too about how you can use GitOps to actually deploy TAP as well. So, I mean, there's multiple ways to get it installed quickly and easily. But if an operations team is doing that, like if that's something that we don't want to have as a developer burden to get that cluster up and running, then the only thing that they really have to install on their laptop is just the Visual Studio integration tools that Aaron showed, the live update plugin. Yeah, and it's a really simple. So if you provide it's a values file that you provide for the install of TAP, and once you have that values file defined, it's a simple 30-minute install to get TAP up and running. We can recreate it really quickly and easily. Cool. All right. So moving on. So Aaron has finished building his application. He's given me the code repository for it. Now I'm going to set up a supply chain that we're going to use as our pre-approved path to production, right? So this is how we're going to get his source code to production. And I'm going to set it up initially. I'm going to walk through how we do that. And then once I have it set up initially as an operator, I'm hands off, right? The supply chain and the workload is already set up. I hand it over to Aaron, and anytime that he builds and commits code, it's going to get automatically deployed and it's going to run through that supply chain. The supply chain that I'm going to show today is our test and scan supply chain. This is one of the 3 out-of-box supply chains that we provide with the Tanzu Application Platform. And it's really important to know here that this is what we provide out of box. This is our opinionated process to get it up and running. But by no means is this the only way that a user has. So we actually encourage our users to look at these supply chains and use them as templates so that they can customize them to their organization's best practices. Say if they don't want to do a source code scan, they can remove that component. Or if they wanted to do, some additional steps in there, whether it's, I don't know, some sort of approval, going out to a CMDB or something like that, they could certainly integrate that as part of one of their supply chains. So just kind of walking through the supply chain that we're going to do. So the first thing that it's going to do is it's going to pull down Aaron's source code and it's going to run some configuration tests on it, or some integration tests on it. It's going to do that using our Tecton pipeline. But again, this is composable. If a user or if one of our customers was wanting to use Jenkins, certainly could pull Tecton out and use Jenkins instead. Once that passes, it's going to pull down using the Gripe scanner, and it's going to do a source code scan on it, make sure there's no vulnerabilities before passing it over to our Tanzu build service that's going to use cloud native build packs to build a container image. It's going to sign that container image and then push it up to our container registry. Once that's complete, it's going to pull that image down and scan it for any vulnerabilities, again, using the Gripe image scanner. And then finally, dynamically build a configuration for the application and deploy it out to Kubernetes on top of cloud native runtimes, which is based on Knative. One of the things I like to point out here is that it is dynamically generating that YAML configuration, those Kubernetes manifests, by looking at the metadata that was attached to the image by the Tanzu build service. So it's app aware in the sense that it knows what type of application it is. So in our case, Aaron built a Spring Boot application. You'll see it as I run through the demo, but it's going to identify it as a Spring Boot. It's going to tag it as such so that when it runs and it builds that configurations, it can add things like health probes into the configuration. So it's dynamically building that. Again, removing the need for our operators and our developers to worry about that wall of YAML configuration, and instead allow them to focus on providing business value. Cool. Let's get into the supply chain then. So the first thing I'm going to do is Aaron has provided me with his source code. So I'm going to hop out and we're going to pull down that source code. So let's just do a git clone. All right, and then I'm going to go ahead and create a workload. Before I do that, let me make sure that there's no workloads there. So upload work list. Cool. So we have no workloads available. And let me do a Tanzu app workload create -f config workload.yaml. This is just pointing to that workload.yaml that Aaron pointed out in our app accelerator, and he made a few changes to it and then committed it up. So a couple key points here. So we're saying we've added a label that says it has tests is true. So it knows that there's tests that need to be executed and it'll search for the Tecton pipeline to run. We've specified the workload type, so that'll help us select the proper supply chain that's going to get run against it. And then Spring Sensors is just the label. So that's what's gonna help us categorize it and organize it. And I'll show you that as I get into the tap GUI. So let's go ahead and create our workload. And the best way that I've seen for this to actually walk to see what's going on is if we just watch the pods. So let's do a kubectl get pods. And we're going to see it actually start to walk through that supply chain that I just outlined. So the first thing that we're going to see is we're going to see a test pod get kicked off. And again, that's our Tecton pipeline that's running. So let's check the logs out here. And we're already past it, but let's just hop back into last. And you can see pulled the source code down. And if I come down a little bit more, it's too much. We're going to see that it's basically just executing a Maven test. So it's using our unit test that we defined in Maven to run the tests. So, and one of the nice things here is that this is completely customizable. So let me show you kind of how that works. So here is the pipeline, and I have a typo in there, so I'll fix it. So this is the pipeline that we've defined that it's pulling in. So you can see the steps right here, again, customizable completely. It's just a Kubernetes resource definition. You can go in here and change those, the test steps that you would have for your application. So let's check our logs again, see where we're at. All right, so we can see that our tests have finished. We executed one test, we had no failures. So our supply chain is going to allow that application to continue running. So let's see where we're at now. Okay, so we have finished our testing pod. That task is completed. We've moved on to our scan task, which is going to pull down the source code, scan it for vulnerabilities. That happened really fast, and we're already onto the build service. So I'll skip past looking at the results of that, and we'll look at the image scan results. It's very, very similar, so I don't want to duplicate it twice in the name of time. But so we're using the Tanzu build service to build the image now. That was the next step in the supply chain. So let's go ahead and take a look at those logs, and I can show you kind of what's going on here. All right, again, scrolling past, let's it. So this is where I wanted to point out and kind of walk through this process. So the Tanzu build service is using cloud native build packs. So what that means is it's going to use open source community standards to build the layers of our container images, which is really nice because it's going to alleviate the need for our operators and our developers to build Docker files, right? So not only do they not have to build them initially, but they also don't have to maintain them. So the really nice thing about that is it frees them up from having to do that work. But two, it also is leveraging open source and community standards for best practices, especially around things like security. So we're not just pulling basic, simple examples of how to build a Docker image off of the internet and using it in our production environments. We're actually using community adopted best practice standards to run those. So it'll mitigate a lot of security risks and best practices around how to build Docker images. All right, so on those, you can see we have 19 build packs that we have installed, and 9 of them have actually been identified by executing the signature of the build pack against the source code. So it's identified that it's a Spring Boot application, and then it has Maven, and we're serving it with Apache Tomcat, right? So it's identified those. It's going to go through, it's going to build all of the layers for our images, and then assemble those at the very end. So let's see, it should be just about done. Yep, okay, so we're finished now. So we can see that it assembled all of our layers for our image. We've built the image, we've pushed it to our registry. One of the things that I also like to point out here is not only have we pushed it, but we also have signed it using cosign and pushed it up to our container registry. And the reason I like to point that out is because the Tanzu Application Platform out of box includes a admission webhook that you can configure to disallow any unsigned images from running in your cluster. So that'll allow you to increase the security posture of your platform and ensure that all of the code or all of the container images that you're running are trusted and verified. Okay, so let's see where we're at now. So our build pod has finished and we're actually getting ready to deploy, but let's take a look at this scan. So we see a second scan pod that has happened. So that is the image scan that just got pulled down. So it pulled down the container image, ran a gripe image scan against it, and checked it for any vulnerabilities. So let's take a look at the results of that. So let's do a kget image scan. And we can see that Spring Sensors has been scanned and completed. So let's dive into that a little bit deeper. Do describe. So here's the results of that image scan. There's a couple things that I like to point out in here. First is that the scan was completed and it found 35 CVEs with 6 medium and 29 low vulnerabilities, which is great, right? So it found some vulnerabilities. But if we hop down here, we see that no CVEs were found that violated the policy. And I'll show that in a second. But basically, this is an image scan policy that we have defined that is letting us know that, or preventing any images that have a critical or high vulnerability from continuing on to our supply chain, right? So we're stopping the application before it ever gets to production, shifting that left and moving more to a proactive nature versus a reactive nature of scanning for vulnerabilities. The last thing that I want to show is that it's successfully sent to our metadata store. Our metadata stores are archived results for our images or for our scans, and it provides some enriched metadata with that as well, which I'll show here in a second. So it gives you a long-term archive view of the scan results versus just hopping through the Kubernetes command line for that. Okay. So now that we've done that, let's take a look at the scan policy so I can show you how that works and how you can modify it. So we have one scan policy. So let me take a look at that. Get scan policy policy. So we can see here our violating severities are critical, high, and unknown. And since we did not have any vulnerabilities that were found of that nature, it allowed the application to continue on down the supply chain. So if we would have hit one of those, it would have paused it right there. Developer would have had to fix those vulnerabilities, and then we would have allowed it to move on. All right, so let's take a look at, now we're going to hop out. Now that we've looked at what that scan policy looks like, let's actually hop out and look at what our insight or our metadata store looks like. So before I do that, let's do get image scan. And I'm going to grab the SHA of our image. And then I'm going to do insight image get digest. Oops. Put it on a new line. All right, so here's what it looks like from a metadata store perspective. So we can see all of the packages that are installed in that particular container image and any CVE that those packages have. So we're able to see there, what our risk and what our exposure is. Conversely, if we wanted to, I could actually search for any images that have the CVE. So if our security team wanted to know what our exposure and our attack surface was for a specific CVE, we'd be able to pull back all those images as well. All right, let's take a look at where we're at. So we are deployed and we missed it, but the pods came up and running, and I'll explain that here in a second. But they started up, they were running, and then they got spun back down. So let's take a look at what we get. Our status. So we can see now that we have our Spring Sensors application, it's ready, and I can dive into the details here. So we can see that we actually have a URL as well. So I could hop out to that URL, but before we do that, let's go and take a look at our GUI, our backstage based tab GUI. Oops, here it is right here. So this is the GUI that we use to kind of surface all of that information in an easy to view way. So I'm going to dive into our catalog that we've defined for Spring Sensors. And here we can see a lot of metadata for this application, right? We can see the owner. If I wanted to hop out to the source code, I could click out to the source code and get a quick view into it. If we had any tech docs defined, we'd be able to see those here as well. I can dive into the runtime resources. So here's our runtime resources and our Knative service that we've deployed. So let's dive into that. And here, again, we're going to get a bunch of metadata about it. So we can see any of the annotations or the labels that have been dynamically generated and applied to it, or we could have specified those as part of the workload.yaml. We see the routes that have been defined for our application, as well as any of the Knative revisions. So as you deploy, you'll get more revisions. You can see 100% of our traffic is being routed to the latest revision of our application. And the other thing I like to point out here is that we have no pods running. So there are no pods running because we're using cloud native runtimes, which is based on Knative. So it's using those cloud native deployment patterns. It has scaled our application back down to 0, right? There was no requests, no workload coming in. So it scaled it down to 0. So if I hop out here and I click the URL, our application is gonna load here. Now you will notice it's gonna take a second. The reason it's taking a second is because that request has come into Knative. It's holding on to it while it's spinning pod up in the workload to serve that request. So it did take a second, but we did get it deployed, and any subsequent request will be instantaneous, just like you expect, because pods are already up and running. So there we go. Now we see our application up and running. And now as an operator, our workload is set up. It's defined. I can go hands off. So let's go back to where Aaron did a pull request. And if we come out here, we see Aaron's pull request. I'm going to go ahead and do a simple awesome review. It looks great to me. Because you can't do a pull request without leaving a comment. So I'm going to go ahead and merge that pull request. And if I hop back here to our platform, and it could take a second, but we're going to see that that pipeline is going to get kicked off. So if I just do a launch, we're going to see that that pipeline is going to get kicked off again, and we're going to start to see the test pod starting. Yep, here we go. So we've already started running test pod, and it's going to work all the way back through that supply chain. The thing that I also like to point out here is that Tanzu Build Service is also in the background watching for any updates to our base OS that we're using or any of the cloud native build packs. If one of those gets updated by our Tanzu network, which is again part of the open source community that we're leveraging for build packs and our base images, it's also going to kick off that supply chain and it'll pick it up right at that build entry point. So we'll build it and then stay in the source code and then get the application deployed. So multiple entry points there, all of which are helping to keep our application up to date and secure.
I'll add one piece of extra context here. So one of these things like this demo is obviously optimized to show like the full end-to-end experience, tightly integrated. And this is works really well with like Spring, kind of like Spring applications. Obviously that kind of is one of our strengths. But the reality is the kind of composability of the platform and the configurability allows you to use the components you need for the language and frameworks that you want to use and the application patterns that you want to use. So if you bring your own container, and you have a rock solid like local dev environment and a kind of an inner loop experience, and you want to use a framework that's not supported at this level, like Spring, you can still do that and still leverage that, like the power of kind of like the path to production of TAP. And same with any other application patterns that you're using that you may want to have like event triggered applications or functions or things like streaming applications that you can use that same developer abstraction that we're providing for a traditional Spring web app for that level of application pattern as well. So the flexibility and the composability of this is really kind of like what we want to focus on. And we want to have the right level of integrated experience for the frameworks and platforms and application patterns. But we know that there's certain patterns in languages and frameworks where it won't make sense to have that really deep integration and let the developer and the operator do what they do best and bring their opinion to the platform. So I've heard this from customers and people in our field that say like, opinions are great as long as they're my opinions. So we want to be able to have people bring their own opinions to the platform where it's appropriate. And that speaks to the kind of the true flexibility and composability of the platform.
So what VMware has been traditionally good at in the more traditional spaces is building kind of best practices to help customers along that path. This is really how to visualize. I understand I can replace this workflow with the Spring kind of centric workflow with a different application development model. It's the plan to kind of show how to borrow the term, replace the batteries in TAP in some of the same KBs we see in the traditional environments.
Sorry, can you?
So the knowledge base articles, the term. So the C kind of best practices. So when I want to replace this workflow with a different workflow, if I have a different opinion, but I'm not quite sure TAP, this is more of a marketing and engineer level question. That seems like oxymoron. Well, anyway, it's a question around, I can't visualize replacing Spring, this Spring workflow. VMware, show me how that's done. Are you guys going to create content around examples?
So there's actually some stuff we're working on right now. Like the default opinion right now is very optimized for Spring web app that deploys to Knative. There's no reason you couldn't have a Go app that deploys as a Kubernetes deployment to the platform and giving you the option to define your own supply chain that enables you to do that from a kind of inner loop to outer loop secure path to production is what will allow you to do and configure that. And then also start to define some of those other out of the box options as well that we see kind of like our patterns that we want to support because we're seeing them kind of commonplace in the market. We want to continue to do that as well. So be able to provide that wide range of support, but allow you to like go deep and provide your own opinion if the platform doesn't provide that out of the box.
Yeah, and I'm thinking, in addition to that, that's exactly what I was thinking of when I asked the question. The second one, which is, as people are going down app modernization paths. One of the primary use cases as people are looking at kind of the Tanzu VCF combination is the ability to take my VM monoliths, start to decompose them. And I would think TAP would be a path to that.
In terms of kind of moving just to like the new kind of like container-based model that would allow you to say, like, okay, now I'm building towards Kubernetes. Kubernetes doesn't have to be, can run anywhere. Right. So I can, like we were talking about earlier in the earlier session, like Kubernetes could be on the edge, just like kind of not in a data center. So as long as that Kubernetes runtime and that target is there, we can target it with a supply chain and deploy your workload and use whatever components of that supply chain or out of the box opinions of TAP that you want.
But for someone who's not, coming out, that's not a VMware Tanzu customer today, right? A lot of the stuff that was shown, like Gripe, for instance, right? That's not a VMware construct, right? I mean, that's an open source tool, right? And there's other pieces of that you could cobble together, and many do. And there's a lot of folks, especially come up that they don't want to get tied into a big corporate tool that solves everything, and they want to do everything themselves. We all know there's pluses and many minuses to that approach, right? What would you say to an enterprise architect that currently has kind of this bespoke build your own approach? If you had to basically give them the 30-second elevator pitch, so to speak, of why should I move into the Tanzu construct? Obviously, supply chain is going to be the big part of it. It sounds like that's the primary value you're bringing at least in this particular module. Yeah. But I'd love to hear that in your words.
I mean, yeah, it's really like configurability, openness, and portability. So you're not locked into this can't only run on like on vSphere and like your data center. This is truly portable across any kind of like Kubernetes deployment target. So like I said, it could be edge, it could be AKS, EKS, GKE, OpenShift, Rancher, whatever you want to like deploy this to. And then you can bring whatever opinions and investments that you've already made. So say you have a CI, CD, or scanning investment. You made a significant investment in it, and it's using the technology that might be like homegrown, that is unique to your compliance requirements, or it's just like you see a really strong alignment with this open source tooling and it's not available out of the box. You can still use that. We don't want to say you can't use that because we know there's already these investments. And we don't want to say like, here's a platform, mold to it. We want to say, here's a platform, mold it to your use case and use these best practices to like deliver these best practices to your developers and allow them to buy into this ecosystem, this path to production.
So you're bringing more enterprise grade best practices to an existing environment that may have grown by default rather than by design, maybe?
Yeah, I mean, you see these all the time out there, the customers who like once like leadership came in and did one thing and then that opinion changed, that leadership left and they're doing something different, or the market shifted. And like, it's a very common thing with these enterprises who buy in and like these kind of like trends in these cycles, like every 5 to 10 years kind of shift and change, but there's investments that of certain things that they're going to have to like support because they have a huge business that has to be compliant with certain things that they have to support. So yes, like being able to have that flexibility to plug those things and those existing investments in is a major part of this.
Thanks.